This is the first video in 7.2, and it's 6.2 in the 6th edition. And we're going to talk some more about matrices. We're going to do some algebra with matrices. Okay, so we're starting out just going to define what it means when we say two matrices are equal, and how to add them, subtract them, and then multiply them. Alright, so two matrices are equal. In order for two matrices to be equal, they have to be exactly the same size. Okay, so these two matrices are both 2 by 2, and they can be equal, but in order for them to be equal, A has to equal 7. Okay? B has to equal 5. Right? C has to equal -2, and D has to equal 0. Okay, so it has to be exactly the same. If I have two matrices that are not the same size, right? So this one is a 1 by 3, this one is a 3 by 1. They're not the same. They can't be equal. It doesn't make any sense. There's no way they can be equal. They have to be exactly the same shape and size. The same thing is true when we add or subtract them. Okay, they have to be the same size because we're going to be matching the exact placement, right? So we add the item in the first row, first column to the item in the first row, first column, and when I get the answer, I put it in the first row, first column. Okay, so very simple, straight across. I'm going to take -3 plus 5, that'll be 2. I got 5 plus 0, that'll be 5. 10 plus 1, that'll be 11. So adding just straight across term by term, so they have to be exactly the same shape and size. Subtracting is going to be the same thing. You know, if I wanted to subtract these, then I would just subtract each term, right? So -1 minus 3 would be -4. -3 minus 5 would be -8. 5 minus 0 would be 5. 10 minus 1 would be 9. Okay, so adding and subtracting just term by term, but they have to be the same size, exactly the same size in rows and in columns in order for us to add or subtract. Okay, so this is called scalar multiplication. Okay, so this number out here is a scalar. So you see that it's a number times, think of it like a parenthesis, right? We're going to distribute the 3 into every single term inside the matrix. So when we do scalar multiplication, it's just a distributing problem, right? Every single term gets multiplied, and it turns out that the answer will always be the same size as the first matrix, because we're just multiplying each one by some number. Okay, so that's scalar multiplication. We can do that, and that's pretty straightforward. The next one is multiplication of matrices, and that gets a lot more complicated. So we'll try some. So here's some matrices we're going to multiply. Notice that these are not the same size. Okay, this one, the first one, is a 2 by 3. The second one is a 3 by 2. The important thing is that these two numbers have to match in order, right? So this is not commutative. I can't switch these around. The two numbers in the middle have to match. The answer when I do the multiplication, it's going to be these two numbers out here, okay? That's going to be the size of my answer, okay? So when I multiply a 2 by 3 by a 3 by 2, I'm going to end up with a 2 by 2, okay? So that's what we end up with. You know, if you can do a multiplication if these numbers in the middle are the same. If they're not the same, you can't multiply those things together. When I multiply, I'm going to take the first row and the first column and the second one and combine those, okay? So, to start out with, just always write these down and then you won't make a mistake, right? As you get going, you'll be able to do it better. But I'm going to write them down in columns, right? I'm going to multiply them term by term in order. So I'm multiplying the 1 times the 2. It's this 1 and this 2, right? The 2, this 2, by this 3. And this 3 by this negative 2. So I'm going to multiply each of these together. 1 times 2 is 2. 2 times 3 is 6. 3 times negative 2 is negative 6. Then I'm going to add them up. Okay? So that's going to add up to 2. Alright, so I use first row, first column. So in my answer, first row, first column is a 2. Okay, so next I'm going to find first row, second column. Okay, so we're going to do, write down the first row, write down the second column. We're going to multiply those. And then we're going to add them. So that adds up to 9. So do you see that I took 1 times negative 1 is negative 1. 2 times 5 is 10. 3 times 0 is just 0. I add them up. I get 9. That goes in. I used first row, second column to get that, so that answer goes in first row, second column. Okay, so remember I was getting a 2 by 2, and that's all that I have left on the first row, because even though my first row in the first one here was 3 across, I only have 2 columns to multiply it by. So I only get 2 columns in my answer. Okay, so now I'm going to look at second row, first column. Okay, so second row is 4, 5, 6. First column is 2, 3, negative 2. I'm going to multiply these. Oops, 8, 15, negative 12. Add them up. So 15 negative 12 is 3. 3 and 8 is 11. So second row, first column is 11. Make a little room here. I got second row, second column now, right? So, second row, second column, barely read that anymore. Negative 4, 25, and 0. So 21 when I add them up. And so that was second row, second column. So my answer goes second row, second column. Okay, so when I multiply these together, I get the matrix 2, 9, 11, 21. All right, here's some matrices, A, B, and C. So let's see what we can multiply together. Okay, let's look at can we do AB? Well, A is a 2 by 1. B is a 2 by 3. So remember, these two have to match. I can't do them. Okay? Could I do B times A? Well, B is 2 by 3 and A is 2 by 1. I still can't do them, right? So I can't multiply A and B together at all. How about B times C? So B is a 2 by 3 and C is a 3 by 1. So do you see that, yes, I can multiply B and C together. Could I do C and B? C times B, well, that would be a 3 by 1 times a 2 by 3, and so the inside ones wouldn't match, so I couldn't. All right, so we can do B times C. Let's do that. Okay, so since I have a 2 by 3, remember, times a 3 by 1, remember that my answer matrix is going to be a 2 by 1. So that's what we should expect to find, is a 2 by 1. So we'll take the first row, first column. Okay, so we have 1, 2, 3, 3, 0, 1. I'm going to multiply them, add them, and that is my answer. First row, first column, which is the only column. Okay? Now we'll do second row, first column. Multiply them, add them, and that goes there. That's all the ones we have, right? I've done all the rows with all the columns. So my answer is this 2 by 1 that's with 6 and 18. One last thing I'll show you here is we can make this whole matrix algebra equation. Okay, so you notice this is a 3 by 3 and this is a 3 by 1, so I can certainly multiply them together, right? The 3 and the 3 match. And the answer will be a 3 by 1, which is what I have here for my answer. Okay? Now, interesting thing happens when I start multiplying first row, first column. I get 2 times x, negative 1 times y, 3 times z, and when I add them together, what I actually get is 2x minus y plus 3z, right? So my first row, first column is going to be this equation, and you notice that the first row of my matrix is the coefficients of that equation. And when I get that equation here, it's going to be equal to these numbers over here, which are my answers in my equations. So what I'm really getting here is a set of equations. So I've got this set of equations, and this is a system of equations, and we're going to use this as an additional way that we might solve a system of equations. And we'll do some more of this in class. Here's your quiz question. I know I'm cutting it kind of close at the end of this 15-minute video, and so hopefully you'll see it, but maybe I'll just put this in the quiz as well, just in case you couldn't see it.